So hello everyone, welcome to my channel. So today in this video we are going to solve this question, right? 2 minus 2 raised to minus x, which is equal to x. This is very conceptual question, so pay attention throughout the video, right? And I have solved many previous video, and if you have any query, any question in any of the video, then you can comment me in the comment box, right? Now, how do we solve this question? Here I have 2 minus 2 raised to minus x equal to x, right? Now, if I try by solving this hit and trial method, then if I put 0, I will get 2 minus 1, but here I will get 0. If I put 1, 2 raised to minus 1, I will get 2 minus 1 by 2, right, which is equal to 1 by 2, right, which is equal to x, not possible, right? So now we have to solve this question. But how do we solve this question? That's the main question, right? So pay attention. First of all, if I bring 2 raised to minus x right hand side, and if I bring x left hand side, 2 minus x equal to 2 raised to minus s. Clear? Now if I multiply by 2 raised to x both the side, how? 2 minus x into 2 raised to x. Same way 2 raised to minus x into 2 raised to x. So 2 minus x into 2 raised to x as it is, this is equal to 1. Now I am sure all of you know about Olympiad function, right? W function. If I have w x e raised to x, then I can write it as directly x, right? Which means this is input, this is our input. If I have an equation which look like x into e raised to x, which means this term and power of e has to be same, then I can directly write this whole term as x, right, according to Olympiad function. And this is in its reverse is also true, which means w reverse x equal to x raised to ex into e raised to x, right? This both are true. So we will solve this question by Olympiad function. Now I have to make arrangement so that I can get both of these term equal, but here I don't have any term related to exponent, so I have to make it, I have to create it. But how do we create it? So pay attention. 2 minus x, right? If I come back to this equation again, 2 minus x into 2 raised to x. Now if I multiply by 1 by 4 both the side, what will happen? You will see later in this question, right? 2 minus x, 2 raised to x, I can write 1 by 4 as 2 raised to minus 2 equal to 1 by 4, right? Now 2 minus x into 2 raised to x into 2 raised to minus 2, right? So I can write it as equal to 1 by 4, 2 minus x into 2 raised to ax minus 2, because the base is same, I can directly subtract the power, which is equal to 1 by 4. Now if I multiply by minus 1, why? Because here I have x minus 2 and here I have 2 minus x. So if I get x minus 2 here, then I will get first of our condition that both the term will be same as here, right? But later we will see how do we bring exponents instead of 2 here, right? So I have to multiply by minus 1 here this side also, so it will become x minus 2, 2 raised to x minus 2 minus 1 by 4, alright? Now I am sure of you know, if I have 2 here, then I can write 2 as e raised to ln 2, right? So I can write e raised to ln 2 instead of 2 here. So x minus 2 as it is, instead of 2 I will write e raised to ln 2, right? I will get here 2 raised to x minus 2, which is equal to minus 1 by 4. Now I am sure all of you know that I can multiply power of power, right? So I can directly multiply x minus 2 into e raised to x minus 2 into ln 2, which is equal to minus 1 by 4. Now I want both of these terms same, but here I have x minus 2 and here I have x minus 2 into ln 2. So if I multiply both the side by ln 2, right, here and here also, then I will get both the side same, which means both of this term will be same, x minus 2 into ln 2, right, which is equal to into e raised to x minus 2 into ln 2, right, which is equal to minus ln 2 divided by 4. Agree? Now I can assume as t, right? So I can write t into e raised to t equal to minus ln 2 by 4. So I can directly write t here. But what about this term? What about minus ln 2 divided by 4? So if I focus on this term, then let's see what will happen. If I if I try to bring minus ln 2 by 4 in this term, then what will happen? See, minus ln 2 divided by 4. If I multiply by 4 in numerator and denominator, then minus 4 ln 2, I will get 16 as in denominator. So I can write minus 4 into ln 2 as it is, and I can write 1 divided by 16. Agree? Now, I want 1 divided by 16 in exponents form. So I can write minus 4 into ln 2 as it is, and I can write it as e raised to ln 1 by 16. Right? So what will happen now? Minus 4 into ln 2 as it is, and I can write e raised to ln 2 raised to minus 4. Agree? So minus 4 will come here, minus 4 ln 2 as it is, and in power I can write e raised to minus 4 ln 2. So again I will get both of this term same, and here I will get exponents like this term, right? And if I assume that, let assume b, right? So it will become b into e raised to b. Agree? So now I can directly write that t into e raised to t, which is equal to b into e raised to b. Now if I apply w function both the side, then w t e raised to t, which is equal to w b e raised to b, right? So I will get equal to, according to this part, if attention here, w of x e raised to x, I can write x. So w of t e raised to t I can write is t, and here I can write b. But what will the value of t? Ax minus 2 into ln 2, and what is the value of b? Minus 4 into ln 2. So I can directly cancel out ln 2 ln 2 both the side. What will remain? X minus 2 equal to minus 4. So if I bring this minus 2 here, x equal to minus 4 plus 2. So I will get x equal to minus 2 as our final answer, right? So I hope you got it. This is, as I said, this is very amazing and conceptual question. I hope you understand this question. See this question one more time, and if you have any query, any doubt, then make sure you comment me in the comment box. And thank you so much for watching this video.